In this module, we are going to look at the question of if I'm given a truth table, how do I figure out what the corresponding formula is? Now, in general, this problem is complicated. What we're going to look at is a simple solution which will generate a formula that may not be the most optimal formula, but one that would be equivalent to the correct formula. So let's say we have this truth table. We have three variables p, q, and r, and we have a truth table where we have some instances that are true, some instances that are false, and we want to figure out what the corresponding formula is. So if I had this particular truth table, it would be something that would be easy to do. Now this truth table is very specific. There is exactly one place where I have the value true, and everywhere else I have the formula evaluating to false. So we have a formula that evaluates to true only if and only if p is true, q is true, r is true. That means we can write it as P and Q and R. Think about this. Make sure you understand how I got this formula from. If you're not able to figure that out, then you should ask me in the class. Now here we have another formula. This is formula X. It also evaluates the true exactly in one place over here, and it evaluates the false everywhere else. So let's see when X evaluates the true. It evaluates the true if P is true, Q is false, and R is false. In other words, X is the formula. I want P to be true, I want Q to be false, that's why I have a not Q here, and I have R to be false, that's why I have not R. So this formula is going to evaluate to true if P is true, not Q is true, which is same as Q is false, and not R is true, which is same as R is false. Now we can take this further and we can look at this truth table where I have two true values, and the specific true values that I have are by taking OR of W and X, and that's why this truth table is going to be for W or X. And so now we can write the well-formed formula as W or X, where W is P and Q and R, X is P and not Q and not R. This is a more complicated instance of the same thing. Here each one of the columns that I have over here, these four columns, all have exactly one true in the truth table and false everywhere else. So we can write this as a conjunction of three variables. So W would be P and Q and R, X is P and not Q and not R, and so on. First thing I want you to do is I want you to verify why I have these formulae the way they are and how they correspond to this truth table. Make sure you understand that. And the second thing I want you to do is see how we got this formula by taking a disjunction of W, X, Y, and Z. So here we have again the same kind of a problem, but here we have a lot more instances where the formula is true and few instances where the formula is false. We could apply the same thing that we did before, but another way to do this that might give us a slightly smaller formula is what we want to look at. Now here we have the formula W, which is sort of the other extreme, which is where we have exactly one false value and everywhere else it is true. So we can see that I can write W to be not P or not Q or R. So this is a disjunction. That means it's going to be false only if all three are false. So I want not P to be false. That means I want P to be true. I want not Q to be false. That means I want Q to be true. And I want R to be false. And that's exactly what we have over here. R needs to be false. Only in that case it will evaluate to false. Everywhere else it will evaluate to true. Now we can do the same thing here. I have W and X. I can write each one of them using disjunction, and then I can take the formula W and X. Remember, W and X will be true if both W and X are true, and that means the formula that we will need is W, which is this, and X, which is this. We can take this one step further. Here we have one more column and one more formula Y, and we have three instances of false. So we got W, X, and Y. Each one has exactly one instance where the formula evaluates to false, and now we can combine this to get W and X and Y, where W, X, and Y are these formulae. What I want you to do again is verify why these formulae are the way they are and how we have combined it into this. A few notes I want to add. We looked at two methods. One of them focused on looking at the true values in the truth table, identifying the corresponding formula, and then combining those using disjunction or OR. This approach is more desirable when the true instances are fewer than the false instances. The other one focused on the false values in the truth table. This is desirable when the false instances are fewer. The reason these preferences work is because the amount of work that is required to be done is proportional to the number of true instances or false instances in the respective method. Note that you can use any of the methods for any of the truth tables. If you use quote unquote the wrong method, that will lead you to do more work, but the formula it generates will actually still be correct. I also want to note that what we discussed is limited. A more general approach is called Karnaugh maps that looks into combining multiple true instances together rather than treating each true instance separately. We won't be going over that in class, but I highly encourage you to look that up. There are nice videos of that available as well as you can find information on that on the book as well. Once again, we have reached the check before you go ahead slide. Here I have two formulae, one for F1, one for F2, and what I want you to do is identify the corresponding formula from the truth table of F1 and the truth table for F2. Note that in the first formula, F1, I have 1, 2, 3, 4, 1, 2, 3, 4, 5 true instances and 3 false instances. So you might want to use the formula where we have false instances that are fewer and use the corresponding approach. For the other one, we have more false instances and fewer true instances, so you might want to use the method corresponding to that. We have reached the end of this module. Go ahead and do the review quiz at this point. If there are questions, please write them down to discuss it with me or the TA.